Welcome to Spark Academy. Once again, we are in chemistry classes. In our chemistry class, we already discussed topics. Already in our last class, we discussed about the chemical bonding subtopic. Let's see once again. One more subtopics in chemical bonding: bond parameters. So, what is our topic today? Bond parameters. From chemical bonding, for Eamcet, we have to expect question compulsory, one question. That one question we discussed already. What are the subtopics? Have a chance to get the question. See, use my coupon. Yeah, see everyone please. Use this coupon. Now, bond parameters. What are bond parameters? So, in chemical bond, bond is very essential. Bond that holds constituents atoms, constituents elements, ions in ionic bond and covalent bond. So, what are the terms we learn in bond parameters, or terms which we use related to the bond? They are called bond parameters. Example: bond length, bond angle, bond order, bond enthalpy, resonance, dipole moment, or bond polarity. These are bond parameters. See once again, what is the first one? Bond length. Second one, bond angle, bond energy or bond enthalpy, same. Bond order, resonance, dipole moment, and or bond polarity. These are bond parameters. Today we are going to discuss only few bond parameters. In that, first one is bond length. What is the first one? Bond length. Yes, see, it is bond length. What is bond length? The equilibrium distance between central atom and other atom. See here. Example here, two atoms. They held together. So what is present between them? Between them, bond is present. Yes or no? Between them, bond is present. So the equilibrium distance between, for example, we consider one is central atom, one more is other atom. So one is central atom, one more is other atom. Otherwise, we take one more example. We take the BCl3 also, no problem. So in that, boron is the central atom. What are surrounded atoms? Chlorines are, they are around the boron. They are called surrounded atoms. So here, how to measure the bond length? The equilibrium distance between central atom and other atom. In the case of this one, same atoms there. One is what? Central atom. One more is other atom. In the case of the BCl3, so what is central atom here? Boron. What about other atoms? Chlorine. So that distance, equilibrium distance, is called bond length. So it is bond length. Clear the bond length? After bond length, yes. So what are the, how we can measure the bond length? Bond length we can measure X-ray diffraction or spectroscopic method or electron diffraction techniques. These are the techniques useful to measure the bond length. Actually, bond length compare with atom, very smallest. Atoms are smallest particles of the matter. Then what about the bond length? So it is not easy to measure. So we have to use the some sophisticated, otherwise, okay, strong devices like spectroscopy, electron diffraction, X-ray diffraction methods. So what are the units for this bond length? Angstrom units, nanometers, picometers we use here. So for example, see here, 1 angstrom unit is equal to how many centimeters? 10 to the power of minus 8 centimeters. What about in the case of the meters? What about in the case of the picometers? See, it is the centimeters, okay, nanometers and picometers. So by this way we converted, okay, easy regarding the units of the bond length, angstrom units, nanometers, picometers. Now 1 nanometer, otherwise 1 angstrom units is equal to how many centimeters, how many meters, how many picometers? 1 nanometer is equal to 10 to the power of minus 7 centimeters. What about in the case of the meters? 10 to the power of minus 9. What about in the case of angstrom units? Okay, 10 to the 10 angstrom units. What about 1 picometer is equal to 10 to the power of minus 10 centimeters. What about in the case of the meters? 10 to the power of minus 12 meters. But we use, according to our syllabus, angstrom units, rarely nanometers, picometers. Now, covalent radius of an atom in homodiatomic molecule. Now we are going to find out the radius, covalent radius. So that is important to give the bond length. So for example, here what? Homoatomic molecule. So what is our molecule here? Homo means same, it is made up of same atoms. Example, Cl2, H2, Cl2, H2, O2, N2. These are examples for homodiatomic molecule. Then in the case of the homodiatomic molecule, okay, what about the covalent radius is equal to half of the internuclear distance. So what about the radius here? Okay, that is, okay, A is equal to B AA by 2, means the distance of the two atoms by 2. Yes. For example, here two oxygens there. The distance between oxygen by 2. Distance between chlorine by 2. Distance between hydrogen by 2. By this way, okay, homodiatomic molecules here what? Bond length. What about then hetero? Okay, what about then hetero? See, covalent radius of an atom, heterodiatomic molecules. So here AB means one is what? A atom, one more is different atom, not like same before, like chlorine, okay, bromine, iodine. Here what? HCl, example for heterodiatomic molecule. Okay, what about HBr, heterodiatomic molecule. So in the case of heterodiatomic molecule, okay, here bond length, otherwise radius, that is what? Distance A and B, okay, that is equal to radius of the A plus radius of the B minus 0.07. It is, we got the electronegativity different, experimental value 0.07 delta x square. So the bond length between a set of atoms. For example, we take some set of atoms like H2O. See here in H2O, what is present? What is present here? OH bond is present. What about in the case of the H2O2? In H2O2 also OH bond is present. What about in C2H5OH? In that also which bond is present? OH bond is present. Now we are talking about the bond length between a set of atoms. Okay, they are different molecules, but OH bond is present in H2O, H2O2, C2H5OH. These three different molecules, but they contain OH bond. That OH bond is in different molecules same. How much that is? 0.97 angstrom units. So what is our intention to explain here? So OH bond same even in different molecules. Here OH bond is same. The distance is same in the case of the different molecules like H2O, H2O2, C2H5OH. All are examples for covalent molecules only. All are examples for heterodiatomic molecules only. The OH bond present all of them, but that is same. That bond is same. Clear? Now we see some examples for this bond length. As increase in S character of hybrid orbitals, the bond length is decreases. So this is what? This is the application of the bond length. Now see, here carbon-carbon single bond is present. Carbon-carbon double bond. Here carbon-carbon how many bonds? 3 bonds. Triple bond is present. Now what about the S character? In the case of the carbon-carbon, S character is 25%. What about in the case of here? What about the S character? Yes. What about the S character here? 1.34. Yes. What about in the case of the carbon-carbon triple bond? S percentage here 50 years. What is your doubt, please? Please write on the chat box your doubt. Yes, the S character here how much? 25. So S character here what? 33.33%, 50. So carbon-carbon, number of bonds increases. So as number of bonds increases, what about the S character? Increases. So S character increases, what about the bond length? Bond length here decreasing. So it is application of the bond length. So what about S character is increasing, here bond length decreasing. So why here carbon-carbon S character is more, bond length is less. How much? 1.20 angstrom units. What about in the case of the carbon-carbon single bond? Bond length is more because here S character is 25%. Yes, by this way. So it is a very important application. As increase in S character of hybrid orbitals, the bond length is decreases. Bond length is decreases. Yeah. Can we go once again? Heterodiatomic molecule. Yes. So heterodiatomic molecules means they are made up of different atoms. Heterodiatomic molecules. HCl contain 2 atoms. Heterodiatomic molecule. HBr contain 2 different atoms. Heterodiatomic molecule. So heterodiatomic molecule, the bond distance, AB, between the distance AB, the radius of the A, the radius of the B. We take total minus 0.07 delta x square. We use this value. Then we will get the in the case of the heterodiatomic molecule, what? The bond distance. Clear? 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 Yes. Now one more application we see. Second application regarding the bond length. As the size of the bonded atom increases, bond length increases. See here. HF, HCl, HBr, HI. What is the common in these molecules? What is the common in this molecule? Hydrogen is common. When hydrogen is common, we can go the next element. What is the next element here? Fluorine, chlorine, bromine, iodine. So as the size of the bonded atom increases, bond length increases. Now see here. So fluorine, chlorine, bromine, iodine. Which one has the Which one has the atomic size is large? Iodine, because fluorine to chlorine, chlorine to bromine, fluorine to chlorine, chlorine to bromine, bromine to iodine, the size of the atom increases. As the size of the bonded atom for common atom is hydrogen, that is increases of the halogen, then automatically here what? Bond length is increases. Bond length is increases. Here I written the order. Which order I written here? Is it increasing order of the bond length or decreasing order of the bond length? Increasing order of the bond length, yes. So HF to HI, bond length is increases. It is the third application of the bond length. After bond length, bond angle. It is the second, okay? It is the second bond parameter. Yes. What are parameters? Okay, I stated. So what are the terms which related to the bond length? They are bond length and they are called bond related to the bond. They are called bond parameters. Second one is bond angle. See here. Okay, this one middle central of that central atom. So this central atom surrounded by how many atoms? Okay, so many atoms there, but we are seeing only 4. Yes. Okay, because for our eye, okay, we are seeing only visible for only 4. Angle between the orbital containing bonded pair of the electrons, central atom in a molecule. Now, this is the central atom. So these other atoms between, what is their orbital overlap there? The orbital overlap will result only bond there. So now what we are doing, the angle between this central atom and other atom orbital, that is called bond angle. That is called bond angle. Once again, the angle between the central, the angle between the orbital containing bonded pair of electrons in the central atom and total molecule. That angle is called bond angle. That angle is called bond angle. Clear the bond angle? Yes. So bond angle. So like bond length we measured, same. How to measure the bond angle? For bond angle measurement also same. We use spectroscopic method. Okay, spectroscopic methods there, first method, but X-ray diffraction, that is useful for bond length, not for bond angle. Now statement, we see the first application regarding the bond angle. As the bond angle increases, so bond angle is not a constant. Bond angle, as the bond angle increases, what about stability of the molecule? Increases. So bond angle increases, stability of the molecule here increases. One more statement, if the number of lone pairs increases, so what about bond angle? Okay, if the number of lone pair of the electrons increases, bond angle here decreases. Now we check. Okay, we take the example, otherwise here only. Okay, as the bond angle, okay, bond angle increases, stability increases. Yes. We take example, which one? We take simple hydrocarbons. Yes. So here hydrocarbons. As the bond angle increases, stability increases. Now tell me, what is the bond angle of the carbon single bond? Carbon single bond angle. Bond angle is 109 degrees 28 minutes. What about carbon double bond? What about the bond angle in the case of the carbon double bond? What about in the case of the carbon triple bond? Here sp hybridization. So what about in the case of the sp2? So bond angle is how much? 120. What about in the case of the sp carbon triple bond? 180. Yes. Now, so here see, as the bond angle is increases, stability increases. So bond angle here increasing. Okay, sp to sp hybridization, sp to sp3 decreasing. So stability also increasing. Now we are confirmed. So what about carbon triply bonded? Yes. Okay, their stability is more. Compare with the alkanes. Now, if the number of lone pairs increases, so bond angle is decreasing. So number of lone pairs increasing. What about the number of lone pairs increases, the bond angle is here decreasing. For example, we take the carbon first. Carbon. Next we take which one? Oxygen. Okay, carbon. And what about oxygen? Okay, next what we take? After nitrogen. Yes, see here. Now carbon in first one. So carbon is the central atom here. It has how many number of lone pairs? Here carbon-carbon bond, number of lone pairs is there? No. Number of lone pairs 0. Now come to the oxygen-oxygen bond. So how many number of lone pairs present here? Number of lone pairs there here, oxygen-oxygen. What about number of lone pairs? So once again we check, yes. So nitrogen first we take, nitrogen 7, after we take the oxygen. So compare with nitrogen, oxygen has 2 lone pairs. By this way, okay, the number of lone pairs increases. Now bond angle is decreases. So carbon carbon, nitrogen nitrogen, oxygen oxygen. So number of lone pairs increases, bond angle is decreases. Now which one has the low in the case of the bond angle? Oxygen oxygen bond. Yes. So it is the second application of the which one? Bond angle. Yes. Now we check once again these examples. CH4, NH3, H2. In the case of the CH4, what is the central atom here? Carbon. Yes. So what about in the case of the NH3? Yes, nitrogen. What about in the case of the H2O? Oxygen. Yes, oxygen. So here we are talking about the number of lone pairs. Yes. Now oxygen, tell me, in CH4, carbon has how many lone pairs? Here lone pairs in the case of the carbon. Yes, lone pairs. So short form I written here is 0. What about in the case of the nitrogen? Nitrogen has here how many lone pairs? 1. Because we know the structure of the ammonia, in that nitrogen is the central atom. And come to the H2O, oxygen is the central atom. So oxygen has here 2. Yes. Oxygen has here 2 lone pairs. Because oxygen atomic number is how much? 8. 1s2, 2s2, next 2p4. Then valency electron 6. It used only to remain 4 electrons in the form of the lone pair. So by this way number of lone pairs increases. So what about the now bond angle? Bond angle increasing, decreasing. Bond angle is here decreasing. So once again number of lone pairs increases, bond angle decreasing. Yes. So it is very good the star mark because important application. We have a chance to expect the question. Yes. Next, see the as increase the S character in hybridization. So what about the bond angle? Bond angle is increasing. For example, see we have here sp3 hybridization, sp2 hybridization, sp hybridization. So what is the S character in sp3 hybridization? What is the S character in sp3 hybridization? Yes, in the case of the sp3 hybridization, S character is 25%. What about in the case of the sp2? What about the S character? Here its S character or percentage is 33.33. What about in the case of the sp? The S percentage 50. Yes. So got correctly now. Yes. Now observe the student please. As increase the S character in hybridization. Please observe this side. Observe the values or S character here. Now, so what about here? As increase the S character in hybridization, the bond angle increases. So we know here the bond angle is high in the case of these hybrid orbitals. Which one? sp. So same. Again we took examples for hydrocarbons. So C2H6 is the example for sp3 hybridization. Yes, because carbon contain all single bonds here. So what about sp2? Example is C2H4. In C2H4 carbon carbon double bond. So hybridization is sp2. In the case of the sp, example is C2H2. So what is the carbon carbon number of bonds? 3 bonds. Yes. So it is example for sp hybridization. S character is 50. Yes. Now I written here what bond angle increasing order. So it is bond angle increasing order. So clear? Bond angle increasing order. So bond angle increasing order in the case of the hybrid orbitals. Bond angle increased order in the case of the hydrocarbons. In the case of the hydrocarbons. Clear? Yes. After, yes. So we see more applications regarding to the which one? Bond angle. Okay, what about the next application? Yes, see the electronegativity of the central atom. Yes, we are talking about now electronegativity. So electronegativity of the central atom. Okay, see here. Electronegativity of the central atom. We have to check here now. See NH3, PH3, and what about ASH3, SbH3, BiH3. So here hydrogen is the common in all, okay, hydrides. So what is the central atom? Central atom is first one nitrogen, second one phosphorus, third one arsenic, next one Sb, last one bismuth. Now we have to check the electronegativity of the central atom. So electronegativity of the central atom from nitrogen to bismuth increases, decreases? Okay, from nitrogen to bismuth electronegativity increases, decreases? Decreases, because nitrogen is more electronegative element. So if En of central atom, what electronegativity decreases? So what is decreasing? Bond angle also decreasing. What is the bond angle in the case of the NH3? Okay, NH3 bond angle is 107. NH3 has sp3 hybridization. So bond angle should be 109 degrees 28 minutes. But due to the lone pair, so here bond angle is decreasing. But every central atom here contain what? Okay, one lone pair. Then lone pair also common. So what is the difference here? Only electronegativity of the central atom. So electronegativity of the central atom, why here decreasing? Why electronegativity of the central atom is decreasing? Because size of the atom increasing. Electronegativity decreasing. So then bond angle also decreasing. See here, very clear. So in the case of the ammonia, the bond angle is 107. So in the case of the bismuth hydride, the bond angle is 90. It's shown decreased. Okay, due to what here? Electronegativity of the central atom. Yes. So one more application now. If the central atom is same, then what we have to do? See here. If the central atom in the bottom of the screen, see the example NF3, NCl3, NBr3, Ni3. Central atom is same. What is the central atom here? Nitrogen. If the central atom is same, other atom electronegativity decreases. So fluorine, chlorine, bromine, iodine. So we know these are 17th group elements. Fluorine to here what? Iodine. What about electronegativity? Decreasing. Then what about the bond angle? Increases. It is opposite to above one. Above one there, electronegativity of the central atom is increasing, bond angle is decreasing. But below, central atom is same. Okay, electronegativity is constant. Then we have to see the second atom. But second atom, in the case of the second atom, bond electronegativity decreasing. Then bond angle is increasing. So bond angle is increasing. See, so here we have a chance to get the question from Eamcet from these two. What? Electronegativity, central atom decreases, bond angle also decreases. If the central atom is same, then electronegativity decreases, bond angle is increases. Okay, you have to focus here very carefully because we have a chance to get question for Eamcet from these two applications. So we have to check once again, and these examples also we have to clearly understand. We have to put the correct answer. Clear? Now after learning the two types of the bond parameters, now third one is bond energy or bond enthalpy. So bond energy and bond enthalpy is same. Bond energy or bond enthalpy is same. See here, we have here molecules. Okay, these molecules, two examples, Here again example C. This example showing what here? Oxygen is the central atom. Oxygen bonded with hydrogens. So down also oxygen bonded with hydrogens. But what about here? It is indicating what? Okay, break of the bond. Yes. So bond has broken here. So the amount of energy required to break 1 mole of bonds. So we have to break here bond. So required energy. So such energy is called bond energy or bond enthalpy. Yes. So how many bonds here we broken? Okay, we did here breaking how many bonds? 1. What about here? 1 bond, because we know hydrogen between 1 bond only present. What about oxygen? Double bond is there. We have to break the 2 bonds. So that is called bond energy, bond enthalpy. Now question. So for 1 bond, 2 bonds. Okay. So number of bonds increases. So what about the bond energy? Bond energy also increasing. So bond energy depends on number of bonds, types of bonds. If sigma bond, more bond energy. If pi bond, so bond energy is less. Clear? Now see, what are the units for bond energy or bond enthalpy? Units kilojoules per mole. Okay, kilocalories per mole. These are the units for bond energy, bond angle. Now example see, hydrogen. If we did what? Breaking between hydrogen bond. So what is the result? How many hydrogen atoms? 2 hydrogen atoms. Now tell me, the heat of reaction here positive or negative? Heat of reaction is positive, because this breaking bond, okay, energy is called what? Endothermic energy. So here required energy. So heat of reaction is positive. Now see the nitrogen. So nitrogen, what is the bond order? In nitrogen between how many bonds present? 3 bonds present. Because nitrogen is bond order is 3. So we have to break the 3 bonds. So here required compared with hydrogen, the bond energy high. So how much here? 941.45 kilojoules per mole. So by this way, number of bonds increases, bond enthalpy increasing. So bond enthalpy is increasing. As the number of bonds increases, that only first application regarding the bond energy. So as the number of bonds increases, bond energy increases. Now see, so what is the first example here? What is the first example here given? C2H6, ethane. Second example is what? C2H4, ethane. What about third example? C2H2, ethyne. All hydrocarbons, but different is bond. So what about in the case of the alkanes? Single bond is present, carbon. What about in the case of alkenes? Double bond. What about in the case of the alkynes? Triple bond. Now we are seeing not a carbon hydrogen bond. We are seeing only carbon bond. So carbon bond, okay, what? Number of bonds increases. So one number of bonds increases. So then what about the bond energy? Bond energy is here increased. How much here? 88. Here 152. Here 200. So bond energy is increasing. What about the now strength of the bond? Strength of the bond. Okay, number of bonds increases. Just now we learned it. Number of bonds increases. What about the strength of the molecule? Strength of the molecule also increases. See, strength of the molecule given. Okay, alkanes, alkenes, alkynes. So strength increased here. So this is the parameter for bond energy and bond enthalpy. Bond energy and bond enthalpy. Now next, bond energy, bond enthalpy. Next application. As increased number of lone pair, bond energy decreasing. So as increased number of lone pairs, bond energy decreases. So we take same now example. Okay, previous example. So which one we are taking again? CH4. S first one CH4. What about the next one? Next one is we take NH3 as So third one we take H2O. So again we see the central atom. So central atom here, which one? Same. Carbon. So nitrogen, oxygen. So what about the number of lone pairs? In the case of the carbon, number of lone pairs are 0. In the case of the ammonia, nitrogen has 1, means 2 electrons. 2 electrons. In the case of the water, oxygen has how many? 2 lone pairs, total 4 electrons. So we are talking only a number of lone pairs. Number of lone pairs 0, number of lone pairs 1, number of lone pairs 2. What about bond energy? It is opposite, decreasing. So number of lone pairs increases, bond energy decreases. Bond energy decreases. Clear? So one more example. So bond energy and bond enthalpy, we completed here number of lone pairs. Okay, number of lone pairs we completed here. So we see one more bond between carbon. Okay, we are taking the bond between carbon. Now bond between nitrogen. So bond between oxygen here, see. So what about here in carbon, what about number of lone pairs? 0. Nitrogen, number of lone pairs? There, 1. Every nitrogen contain 1 lone pair. In the case of oxygen here, yes, we show here easy then. Here what? 0. Here what? 1. Here what about 1, 2, 3, 4? 1, 2, 3, 4 by this way, yes. So we repeated again this one. As increase number of lone pairs. So bond energy what? Decreases. So bond energy decreases. Okay, this is explained by VSEPR theory also. That is clearly explained about the bond energy, bond enthalpy. Bond energy, bond enthalpy, yes. Now after bond energy, bond enthalpy, we see the bond order. So what is the meaning of the bond order? Okay, number of bonds between the atoms. Okay, number of bonds between 2 atoms in a molecule. So number of bonds, okay, between 2 atoms in a molecule. That is called bond order. Now what is the bond order here? Because only single bond is there. So bond order, BO, bond order is equal to 1 here. What about here bond order? Because here 2 bonds there. Bond order is equal to 2. What about here bond order? Bond order is, okay, if they mention it triple bond, means 3, not 5, 3. By this way bond orders 1, 2, 3. Now bond order increases. What about the bond energy? Increases. So bond order increasing, bond energy also increasing here, see. So by this way, okay, we calculated, we see the bond order depends on the what? Number of bonds. Depends on what? Number of bonds. Clear the bond order. Now we have one small, okay, table. With the table easily we confirm the bond order. We take total number of electrons. Total number of electrons. So what about down? Bond order. If total number of electrons are 10, okay, 11, 12, 13, 14, 15, 16, 17, 18. So easy. So total number of electrons, we written that 10 to 18. What about the bond order? Bond order here, if electrons 10, 1. Next to 1.5. Next here 2. What about 2.5? Next number, total number of electrons 14. Their bond order is 3. 15 means 2.5. 16 means 2 here. 17 means 1.5. 18 means 1. Yes. So this table useful, okay, to get the bond order of the molecule. So this table useful to get the bond order of the molecule depends on what? Number of electrons. So number of electrons also depends on what? Atoms. Yes, now we see examples now. Yes. So we take the example, first one. Before example, example C. Oxygen, oxygen. What is the bond order of the oxygen, oxygen? What is the oxygen, oxygen bond order? 2. Yes. What is the bond order of the hydrogen, hydrogen? 1. What is the bond order of the nitrogen, nitrogen? Yes, 3. Yes, this is the bond order. Yes. Now, according to our table, we check. First, we take the H2. Okay, in H2, how many total number of electrons present? Hydrogen 1, hydrogen 1. Okay, so total number of electrons, it is easy. So not required to go this one. Yes. So we see now what is the bond order in the case of HH1. So we take the now En2. We take En2. So En2, how many nitrogens there? 2 nitrogens. Every nitrogen, okay, the number of electrons 7. 7, 7, how many total? 14. Yes or no? 1 nitrogen 7, 1 more nitrogen 7. Total number of electrons 14. So what is the bond order of the N2? 3. What is the bond order of the N2? 3. Yes, very easy. Now we take the very important in exam O2, O2 plus, O2 2 plus. It is a star mark question. Yes. O2, O2 plus, O2 2 plus. Now we have to check their bond orders. Now what is the bond order of the O2? O2 means oxygen. So oxygen atomic number 8816. Yes or no? 2 oxygens there. Total number of electrons in the case of the O2 16. So what is the bond order? Here 2. Yes. So what about now O2 plus? Total number of electrons 8816, but 1 electron less is there, 15. Then what about the bond order? 2.5. Now O2 2 plus 8816, but we have here how many? 2 electrons less. So 14 electrons. What about the bond order? 3. Yes. So can you write there increasing bond order? Yes, we write O2 less than O2 plus, O2 plus less than O2 2 plus. It is the increasing the what? Bond order. So bond order increases. What about the bond strength? What about the bond order increasing? What about the bond energy? Increasing. What about the bond energy? Increasing. What about the bond length? Decreasing. Yes, by this way. Okay, one parameter, other parameter, they have the correlation. Yes. So by this way, one more example. Okay, Cn minus. Cn minus is called cyanide. So what about the bond order of the Cn minus? So carbon, how many electrons there? In carbon, total number of electrons 6. What about nitrogen? 7. So minus means we have to what? Add plus. So here what? 6, 6, 12. Yeah, total number of electrons 14. So 14 means number of electrons here 14. What about the bond order? 3. Yes. By this way, this table is useful to find out the bond order of the covalent molecules. Bond order of the covalent molecules. So after these, bond parameters, now we see the some examples again. So it is about our Spark Academy. So coaching, what about offline and short term regular courses also there. 2 branches also there, Narayanguda and Medipatna. So online coaching also there, daily on demand live sessions also present. Now we see examples. So first example number 1, see. The species having bond angles of 120 degrees. Here given, first one is chlorine trifluoride, nitrogen trichloride, boron trichloride, phosphorus trihydride. So in that, which one is contained bond angle is 120 degrees. So which one is contained bond angle is 120 degrees. So here 2 methods there. One method, first we have to find out the hybridization. With the help of hybridization, we have to find out pick the answer. Second method what? If we know already hybridization, we see the central atom position now. Yes, See here central atom. So 120 means we can expect easily. What is the hybridization? So hybridization very important in our syllabus. SP, SP2, SP3. So SP means what about bond angle? 180. SP2 means 120. SP3 means 109 degrees 28 minutes. Yeah, now yes, see bond angle 120 means SP2 hybridized one. So here chlorine is the central atom. Chlorine valency electron 7. Okay, 3 used. Remain how many there? 4. Okay, in the form of the 2 lone pairs present here. What about nitrogen? Nitrogen here has 1 lone pair. What about here boron? Boron atomic number is 5. Okay, and what about valence electrons? 3 used. And if see the geometry of the BCl3, boron is the central atom and chlorines, they are what? How they are look like? Planar. So this geometry is trigonal planar. So when geometry is trigonal planar, it's what hybridization is sp2. What about bond angle? 120 degrees. So what about pH3? pH3 also like nitrogen, chlorine has 1 lone pair. So then what is the answer? So answer is C, BCl3, boron trichloride. So hybridization is what? Hybridization is sp2, bond angle 120. So this one having bond angle is 120 degrees. So now next question. Consider the molecules. Given molecules here. What is the first molecule? CH4. Second molecule ammonia. Third molecule water. Which of the given statement is false? Question number 8. Question number 8, we have to pick what? False statement. We have to pick the false statement. Yes. So we check the one by one. Statement 1. The HOH bond angle is, okay, in H2O is smaller than the HNH bond angle. So the HOH means here what that is in the explaining. Otherwise given HOH bond angle in H2O is smaller than HNH bond angle. So what is the bond angle in ammonia? 107. What is the bond angle in water? 104. Then the HOH bond angle is H2O is smaller than HNH bond angle. Yes, it is the true statement. Yes, this is the correct statement. Now B, the HCH bond angle in CH4 is larger than the HNH bond angle in NH3. So what about HCH bond angle? 109. Okay, 109 degrees 28. Yes, minutes. So what about the HNH? In that, what about 107? Then, so this statement also true. The HCH bond angle in CH4 is larger than the HNH bond angle in NH3. So what about the C now? The HCH bond angle in CH4, the HNH bond angle in NH3 and the HOH bond angle in H2O all are greater than 90. Yes, the third statement also true. Yes. Then statement 1, statement 2, statement 3 are true. So what about the we can get what? Statement 4 is false, but we have to check. The HOH bond angle in H2O is larger than the HCH bond angle? No, because H2O bond angle is 104 and what about the HCH bond angle? 109. So it is what? Not larger, shorter than the HCH bond angle. So what is the answer? Answer is D. So D is the false but correct answer regarding to this question. Yes. Now can we go the next question? Yes. So next question is the correct order of increasing bond angles in the following triatomic species. So what is the meaning of the triatomic species? Molecules they contain 3 atoms, they are called triatomic species. are given down triatomic species only. Okay, their bond angle we have to what? Increasing bond angle. So increasing bond angle. So I given the hint for you. Now check the hint. Structures of the NO2 minus, NO2 and NO2 plus is given as. So what about the NO2 minus, NO2? They have angular structures. What about the NO2? It has the linear structure. Now see and tell me what is the correct answer. So correct answer is D. Why? Answer is D is correct. Because hint is there. After seeing hint also we have to analyze the answer. Yes, see the NO2 minus, okay, less than, because they are given 115 degrees. NO2 minus has 115. Why? It has the less bond angle due to the what? One lone pair. Okay, what about here? Only one electron. So what about in the case of NO2? No lone pairs. Yes. So what is the answer then? Answer is D. Clear? Okay, next question now. Next, the correct order of the SIBO bond length among SIBO carbon monoxide, CO3 2 minus carbonate ion and CO2 carbon dioxide. So here we given the CO3 2 minus has how many resonance structures? 3. CO2 has how many resonance structures? 2. What about C? CO3 T minus and CO2. So here more single bond character in resonance bond, more is the bond length. So here we are saying indirectly the resonance hybrid. So what is the resonance hybrid here? So which is the, okay, from 3 resonance or 2 resonance structure, that is called what? Resonance hybrid. So more single bond character in resonance hybrid, more is the bond length. Hence the increasing bond length is SIBO less than CO2. CO2 less than CO3 2 minus. So what is the answer? Answer is here, okay, C. Yes. So can we go the next question? Yes. Okay, next question is 15th question. The correct order in which the oxygen bond length increases in the following is. So see here, O2 contain oxygen bond, H2O2 that also contain oxygen bond, O3 even that also contain oxygen bond. Now the correct order in which oxygen bond length increasing in the following. So what is the answer? So answer is D. But how answer is D? See, the bond lengths oxygen in O2. How much? 1.21. Okay, how much here? 1.21 angstrom units. What about in the H2O2? 1.48. What about in the O3? 1.28. So what about then? Which one is least? O2. Okay, after which one is least? O3. So after last one, H2O2, yes. Therefore, the correct order of the oxygen bond length in H2O2 is greater than O3. O3 is greater than O2, yes. So these all three contain oxygen bond length. Yes. So next, next for you some homework questions. In that we took which one? The correct sequence of increasing the covalent character. So we are learning here bond parameters, that is in covalent compounds only. So now you have to check this, give your answer. The correct sequence of increasing covalent character is represented by. Now next question, dipolar. So dipole moment also one of the bond parameter. So H2O is dipolar, whereas BeF2 is not. Why? So what is the reason? You have to find out. Yes. So subscribe. So congratulations to all our students, because this is the graph showing our results. So day by day our results are increasing. So what about the same? So not only the JEE mains and same NEET also. Okay, for our NEET students, they are in good colleges. Few are in. Okay, they got the free seats also. So thank you, students. Okay, here we seen today few bond parameters. So in our next class, remain bond parameters. Okay, we'll learn. So thank you, everyone. So your doubts there any? I posted that. You have to say that answer. Check that. Because you are in chemical bonding already. Polar, non-polar, we can tell what with the help of symmetry or not. What? Unsymmetry also. So molecule is symmetrical and unsymmetrical molecules also there. Yes or no? On that we say polar or what? Dipolar or polar. Polarity we can say with the help of what? Symmetry. So plane of symmetry, axis of symmetry. Yes or no? So symmetrical molecule or unsymmetrical molecule. On that we say what? Polarity, dipole moment. Some symmetry also required. So what is mu? Mu polarity means mu not dipole moment. Yes. For example, carbon dioxide is there. Is polar or non-polar? Carbon dioxide polar. But what about the symmetry? Is it symmetrical or unsymmetrical? Symmetrical. CO2 linear, symmetrical. So what about dipole moment? Zero.
I took permission.